Okay, we seem to have a red light, so let's go ahead and get started. I was really interested in this question of the day that we used from the last time, which is what are your plans about CSE 143 in the future? So not clear how representative this is, but 44% saying yes. I was particularly interested in the 29% saying maybe. I'm biased, I guess. I would love it if all of you decided that you wanted to go on to 143. Well, maybe not all. Maybe some of you, if you found that that this is just kind of not enjoyable. It's been an interesting place to visit, but you wouldn't necessarily want to live here. So maybe not. But I think there are an awful lot of people who find that there's something interesting about what they've done here. Not quite sure. I've had an awful lot of people who talk to me about how they plan to take just 142. They didn't expect to enjoy it or to enjoy doing the homeworks, but actually they're surprised that they do enjoy it more than they thought. Maybe they'll try 143. Anyway, so it doesn't surprise me a lot, but I would encourage those of you who are maybes to seriously consider it and to think about taking the class just to see whether you like what we do next. I mentioned last time that I would, in these coming lectures, I'd be saying a little bit more about the critter assignment. So today I wanted to zero in on a particular thing. In the assignment write-up, a lot of stuff here to read about how it works and so forth. We talked about a lot of that last time. I did want to just kind of point out to you, it's here in the write-up, so in a way I shouldn't have to do it, but I just wanted to point out that there's a lot of discussion here about how the style points are going to be awarded. So there's a discussion here about that it matters to us for your Husky class, whether it's a creative Husky class or if it's just a copy of the kind of things that we've already shown you, or whether there's something a little bit different, so that's part of what we'll be looking at. This paragraph here talks about some very basic style things we've been doing all quarter, but also mentions the idea of encapsulating data. So, excuse me, I had mentioned the idea that all of your fields have to be declared to be private. So as I mentioned last time, you're going to be picking which fields to have for each of the classes, what state information you need for each of the classes, but all of that state information has to be declared to be private. There's also a requirement that you initialize your fields in constructors. So it works to initialize a field outside of a constructor, but this is a style issue for us, so that's something that you want to be paying attention to too. Mentions the idea of doing the pseudo-random numbers, that you could use math.random if you wanted, but you can also do a random object. But if you do a random object, it has to be a field that's initialized in the constructor. There's some description here about what's going on with this paragraph is actually an important one to read as well. It's talking, you can read the description of what's going on, but there are the different methods that you're writing, and so there is state information you'll be keeping track of. These critters change their behavior as the simulation progresses, and so you'll change the state of your different critters to have them display in a different way. And what this mentions in here is that all of the changes in state, so if you're changing the value of a field, all of those changes have to happen in the getMove method. Suppose, for example, that you put some change in your toString method. Then if I called toString over and over and over again, I'd get different answers, if you're potentially changing the state in toString. So toString should not be changing state. GetColor should not be changing state. All of the changes in state should be happening in the getMove method. So that's what's described here. That's an important thing to understand as well. I'm sure initially you'll just be getting everything written, but you're going to want to review this before you would submit a final version to make sure that you're going to be getting maximal style points on this homework. So lots of information on this page about how the style points are going to be awarded. Okay, Well, we're going to be doing various things in the next few lectures. There are some leftover topics in Java that are important to understand. I think if you want to have a reasonable sense of Java, you need to know these things. Now, normally there'd be a final exam and we'd be testing it on the final exam. We're not doing that this quarter. But these are very practical and important things to know about Java. So I would recommend that you kind of keep watching the lectures and stay with us, because this is stuff that is important to know about. I'm going to be using the document camera for a bit. So let me try sending that to the projector so that I can be working on the document camera instead. And what we're going to be talking about today is something that's known as inheritance. And this is considered a very central idea in object-oriented programming. I mentioned state and behavior and encapsulation, those ideas. And that's a lot of what object-oriented programming is about. But a lot of people who are object-oriented programmers would say, if you don't have inheritance, then you don't have OOP. You don't have true object-oriented programming. So this is kind of considered an important idea. I want to begin with a non-programming example. And I've always kind of done this in my introductory inheritance lecture. And I've always kind of thought of these non-programming examples as things that you wouldn't do in code. And then my co-author, Marty Stepp, decided to actually turn this into actual code. So you'll find that in chapter 9, he turns this employee example that I'm going to do into something where he has actual Java classes. So that reinforces what I'm doing here, although this was kind of intended to be something that was not necessarily related to programming. So the idea is that we often come up with some kind of a hierarchical diagram to describe different categories and how they're related to each other. So like a company might have a lot of different employees, and they might classify some of them, say, as being clerical employees, some of them as being professional employees. I don't know how much you've heard this term, but people will talk about going to a professional school, the law school, the business school, getting an advanced engineering degree, often lead to what we think of as is professional, versus clerical, which is a kind of a more generic term for office management and all of the different kinds of things that you might do there. Among the different kinds of clerical workers, there might be a kind of clerical worker known as a secretary, and there might be variations. There might be something which we would call a legal secretary. There may be some of these secretaries that have some special skills that we would make them a legal secretary. Among the professionals, you might have lawyers, for example, the ones who went to law school. You might have engineers, that have advanced degrees in engineering. Anyway, it's a way of kind of dividing up the company into different categories of employees. I'm going to relate this to Java in a minute. Maybe it's not surprising, but these are going to become classes in Java. But the idea here is just these are descriptions of different kinds of things. There's a term that we use for this in object-oriented programming. We talk about the idea of an is-a relationship. So it's supposed to be true that as you kind of move through these, look up the hierarchy here, there should be an is-a relationship that holds. So it should be true that a legal secretary is a secretary. It should be true that a secretary is a clerical worker. It should be true that a clerical worker is an employee. It should be true that lawyers are professionals and that the professionals are employees, engineers are professionals, and professionals are employees. So kind of as you look up the hierarchy, there should be this is-a relationship that holds. So that's kind of a rule of thumb that people use in object-oriented programming. Well, I want to give you a sense of how this is helpful. And the example that I give that's also mentioned in the book is that if you go to work at a large company or university or something like that, what they'll typically tell you is that one of the first things you have to do is to go to an employee orientation. So So there might be some orientation for generic employees, lots of people in a room, or I guess nowadays lots of people on a Zoom video call, and they might give you, if it was physical, they might pass out to you an 80-page booklet. Nowadays maybe they'd point you to online web pages, that have this information, but there's kind of a booklet for new employees that tells you about the company, maybe a little bit about the history, things like that, and it might tell you about various kinds of procedures. What are the benefits that we offer? How do you sign up for health care? How do you sign up for retirement? There might be in here some form for applying for vacation. Maybe there's some special yellow form you're supposed to fill out when you want to apply for vacation. So there'd be kind of a generic booklet that is given to all of these employees, and you're kind of told these are some of the policies and procedures of the company. Suppose you're a lawyer, and you went to that employee orientation, and you come back the next day to your division, and they might hand you a little 5-page booklet where they say, well, this is kind of a supplement to the 80-page booklet that applies to lawyers. And so what do you have in that supplement? Well, there might be some extra things that lawyers have. There might be extra forms for them to fill out. There might be extra rules, extra procedures that don't necessarily apply to other employees, but they apply to lawyers. So that might be described in this little 5-page booklet. And the idea that we're going to be focusing on a lot in the code examples that I'm going to give you is that you have the ability to override one of these things. So maybe the 80-page booklet said to fill out this yellow form when you want to apply for vacation. You might say, well, we don't use the yellow form here. We have you fill out a pink form. So we've got our own form for applying for vacation. It's different. It overrides what otherwise would apply to you. So there's kind of an understanding that the 80-page booklet applies to everybody, in general, but depending upon which division you're in or something, there might be some extra things that apply to you, and there might be some overridden things where the standard procedure is not applicable to you. There's some different procedure. You use the pink form instead of the yellow form. So that's a lot of what goes on with inheritance. You could imagine that engineers are given a little 3-page booklet, secretaries are given a 4-page booklet, something like that. So, and one of the questions that I normally ask when I have an audience is I'll say, is this a good idea to do it this way? Why have the 80-page booklet? Couldn't you merge the 80 pages and the 5 to make a booklet just for lawyers that has everything? Merge this with that, and make one just for engineers. Merge this with that and make one just for secretaries. Why not specialized booklets that have everything? Would be kind of the question. And I get lots of interesting answers, some of which have to do with kind of a way in which the analogy doesn't hold very well. But I usually get somebody who comes up with an answer that does match what we're going to be thinking about when we turn to programming and think about how this applies to programming. And that is, what happens? So you could imagine making a whole bunch of specialized booklets. So what happens if something changes? So we know, for example, that healthcare has gone through huge changes from the government, in the last 15 years, Obamacare, all sorts of things that have changed. And, and now in the new era, the Congress is passing all sorts of things. There's all sorts of things that are changing all the time. So you can imagine that you'd want to update the 80-page booklet. And so it's nice to have a single 80-page booklet that you can update that takes care of most of the changes. If you have all these variations, you've kind of merged it into a whole bunch of different specialized booklets, and something changes about healthcare, well, you have to go in and change every one of those individual booklets, and that's a lot of work. So we like having one generic copy so that when something changes, we can make the changes in one place. And there's a term that programmers will use for this. We talk about the idea of code reuse, and there's a kind of a notion of maintenance of code. But object-oriented programming, inheritance, is particularly good at solving the problem of how to reuse code without having to have a lot of copies of that code. So how to have one copy of the code instead of having, 45 copies of the code. So instead of having, say a method that you would put in 45 different classes, you have one version of the method that's in this top class, and then the one copy of the method applies to all of these different classes. The code reuse, code sharing in that sense. One copy that applies to all of these different ones. So that's kind of the main reason that we want to do the inheritance, is to be able to have good code reuse. Okay, well let me talk a little bit about how this applies to programming. So as I said, this is going to, instead of employees and lawyers and things like that, we're going to be thinking about classes. So if we had a public class called A that had some things in it, this is the kind of class that we've been writing, a public class with some kind of a name. And if I had a public class called B, I can say extends A. So there's an extra clause that I can put in the header of a class, an extends clause, that says what kind of inheritance relationship it's going to have. And in the same way that in this diagram I was drawing here, we kind of had a hierarchical type thing where one thing is above another. We would do that here. We would put A up here, and we would put B down here. So we would say that A is at the top of this hierarchy, and the B extends the A. This would be like secretary versus legal secretary. So B is a variation of the A, but it might, for example, have extra things. A legal secretary might be able to do extra things that a secretary can't do. There's some terminology for this. We talk about this as the superclass, and this is the subclass. But you don't have to worry about that terminology. It's a little bit misleading because it kind of implies that whatever is at the top is super, super, super. And if you look here, an employee, what do you know about an employee? You don't know anything. Whereas the sub thing here, which, it's the sub thing, the legal secretary. Legal secretary can do lots of things. So actually the legal secretary in this diagram is very sophisticated. So the subclass was the one that was very sophisticated. It's a little weird that, super versus sub, the way that those terms are used. But in any event, this B extends A. Now, the interesting thing to understand about this is just by putting in these two words, just by saying extends A, B objects automatically inherit the state and behavior of A objects. So they automatically will have the state and behavior of an A. Just by putting the extends clause here, they have that state and behavior. Now, you might wonder, well, what's true of A then? And Java has various rules. We've seen some of these rules, like, if you don't introduce a constructor, Java will make one for you. So we've seen a lot of cases where if you don't say something, Java will do it for you. And it turns out that if you don't have an extends clause, Java will include an extends clause for you, that it will include extends object. So there's a special class known as object. I've always found this kind of interesting because, if you want to have inheritance and have an inheritance hierarchy, then there has to be something at the top, something that doesn't extend anything else, the most generic of all things, and that's going to be the object class. It reminded me of when I was studying philosophy, and Aristotle was talking about, this causes that. There was the unmoved mover, the thing that didn't have an initial cause or whatever. The unmoved mover, the non-extension class, is object. Object is the one and only class in Java that doesn't extend another class. It's kind of the special class that has that property. So that it's like employee, it's at the top of the whole hierarchy. So everything in Java extends the object class one way or another, either directly, like here the A class extends object directly, or indirectly because it extends something that extends object. So everything kind of goes back to object eventually. Okay, so the idea of adding the little extends clause in there means that we inherit the state and behavior. But remember, we can add new state and behavior, so we can have extra things, and you can override. Now, there's a lot of interesting stuff to know about inheritance, and there's a lot. The Chapter 9 has a lot more than what we're going to study. I only want you to understand a limited amount of it at this point. It kind of gives you a flavor of what's going on with inheritance without having to understand all the details. In the 143 class, we talk about in more detail a lot of kind of the subtle things that go on with inheritance. But you'll see that the kind of questions that I would ask you to practice, it just gives you a flavor of inheritance. And I think that's a good thing to do, is to kind of, to do some of these exercises so that you've gotten the sense of how inheritance works, the basic idea of inheritance, so that you'll know that Java has this and it's kind of there. But then, whether or not you go on to 143 and understand it in more detail, some of you will, some of you won't, and that'll be just fine. Now, I have made a handout for today. I didn't show this when I had the computer up before, but there's a link on the main class page to the inheritance handout for today. Normally, I'd be having TAs pass it out. But if you have a printer available, you can do printing. I would recommend that you pause the video for a moment and print that inheritance handout, because I think you'll find it a little easier if you can write on the inheritance write-up itself. But I'm going to be showing it to you, so you don't have to have it. But anyway, if you have the ability to print, I would print. So this is what's kind of on that handout, is there's a problem here, an inheritance problem, that's an example of the kind of problem that we put on our final exam. And as I said, you're not doing a final exam, but I think that it's useful for you to get to the point where you can answer this kind of question about inheritance, because it will give you a good basic understanding of inheritance. So I'm going to be showing you some sample tests next week. I'm going to ask the TAs to spend at least a little bit of time in section next week doing an inheritance problem. So it's good to practice it even if you're not going on to 143. This is not one of the harder questions on the exam. If you don't have the benefit of this lecture, it's like impossible. It's crazy, but you wouldn't know how to do it. But I think you're going to see that this is a fairly mechanical thing that you can learn without too much trouble, and so I think it's worth your while to do that. Okay, so how do these questions work? Well, I have several different classes here, so let me just kind of indicate here. That's a public class known as foo. There's a tiny little class here known as bar, and then there's a class here known as baz, and then there's a class here known as mumble. So I have 4 different classes here. I have a foo, bar, baz, mumble class. So there's 4 different classes in this write-up. So that's kind of one of the things, is to be identifying what the different classes are. The first thing I do when I approach a problem like this is to draw the inheritance hierarchy, the kind of thing that we had with employee and so forth, or what I was showing here with, that B extends A. So you need to figure out which of these is at the top of the inheritance hierarchy. And what you'll find is that of the 4 different classes, one of them will not have an extends clause. And that's the one that's going to be at the top of the inheritance hierarchy for this little sub-problem. We kind of know that there's that since it doesn't say, that means it extends object. Since foo doesn't say what it extends, we know that it extends object. But this isn't something you're going to have to know about to solve the kind of problem we're doing here. So we kind of keep it in mind, but we don't have to actually put that into our diagram. Now, this one I particularly put together in a kind of a more straightforward way. If you look at some of the other problems that we work on, so like there's a page 2 that's on the back of my version of the handout that has a problem 2, And I'm not going to go over this one with you today. I'm going to leave that for you as something that you can work out. But so you have to kind of recognize which one is at the top of the hierarchy. And the very first one that I list is not the one that's at the top of the hierarchy. So I was making things a little easier here by having it be the first one. But in general, I mix it up a little bit to make sure that you're understanding kind of the idea of what would be at the top. So foo is the one at the top because it extends object. It doesn't extend any of these others. So then let's look at the other extends clauses and see what extends foo. Bar extends foo and baz extends foo. Mumble does not. So we have the foo class here, foo, and we have that bar extends it and that baz extends it. So those are our two classes that extend the foo class. And mumble extends the baz class. So we would draw it like this. So that's how we would draw the inheritance hierarchy for this particular little subproblem. So very important thing to do is to do the inheritance hierarchy first. Then I'm going to recommend a way of doing these problems when you first start doing them. It might be that you don't need to do what I'm about to do, or you could kind of do it without formally writing it down in this way. But I like making a table. So what I'm going to do is, look, I know that I have these 4 different classes involved, that there's the foo class, there's the bar class, there's the baz class, and there's the mumble class. So I know I have 4 different classes. And let me tell you that what I've done with these different inheritance examples to keep it relatively simple is that I include a toString method and a method 1 and a method 2 in the top level class. So there will always be a method known as toString. There will always be a method 1. I'm going to abbreviate it with an M1. I hope you'll allow me to do that. And a method 2 that I'm going to kind of label as M2. So in terms of our table, every one of these classes is going to have a toString, a method 1, and a method 2 because the class at the very top of the hierarchy has it. So foo will have all of these, and then the other ones inherit from foo, which means that they're all going to have this as well. By the way, the toString is an interesting one because even if foo did not have a toString, they would all have a toString because we've seen this, right? That we can, when we printed out point objects, we got that crappy toString method. When we print out arrays, we get that crappy toString method. Well, that toString method is in the object class that I've crossed out here. So the object class has a method known as toString, and that's why every class in Java has a toString method, whether you define one or not. So if nothing else, you get the crappy one that's in the object class. But what we want to do in general is to override that and do our own version. So foo does override the toString method to give it a different definition. So there are different things to think about when you don't always have all of these methods implemented. But as I said, the 142 version of an inheritance question is relatively simple. So let's see what the foo class does. Let's look at that one at the top of the hierarchy. For its toString method, it returns the string foo. So I'm going to put foo here as the behavior of the toString method. Its method 1 prints out foo1 as a println. So it produces one line of output that says foo1. And its method 2 produces one line of output that says foo2. So that's the behavior of a foo object, is it returns the string foo, it prints out foo1, it prints out foo2 for these 2 methods. So those are how those 3 methods behave for a foo object. So that's kind of my first entry in the table. What about a bar object? Well, bar extends foo, so normally bar would inherit all 3 of these behaviors. So if bar didn't have any code in it whatsoever, it would have a toString that returns foo, it would have a method 1 that prints out foo1, and would have a method 2 that prints out foo2. That's that inheritance idea. Just by saying extends, you automatically inherit all 3 of those methods. You inherit all of the behavior just by saying extends. But it also has the ability to override, and in fact it does override method 2 so that it prints out bar 2. So it prints out bar 2 for its method 2. It normally would have inherited a method that printed out foo 2, but it overrode it. We use the pink form, not the yellow form. You know, that's that overriding idea. It does not have definitions for these methods, so it inherits them. So it has a toString that returns the string foo, and it has a method 1 that prints out foo1. So it has 2 inherited methods and 1 overridden method that it does. All right, Baz also extends foo. So Baz would normally inherit the 3 foo behaviors, but let's see what's in the class. Baz has a toString method that returns the string Baz, so it overrides the toString method so that it returns the string Baz. And it overrides, oh, that was mumble, and it overrides method 1 so that it prints out Baz1. So it prints out a Baz1 for its method 1. And it does not have a definition for method 2. You can see here there's no definition for method 2. So it inherits the foo class's method 2, which prints out foo2. Be careful when you're doing this table to remember that Baz is related to foo. Baz is not related to bar. Baz is related to foo. Baz inherits from foo. You know, not, you know, these are kind of equal in the, you know, in the hierarchy. So it prints out foo2 for its method 2. Then mumble. Mumble extends Baz. So normally mumble would inherit these 3 behaviors from Baz because it's an extension of Baz. But it has a method called method 2. I mean, it has a method 2 that prints out mumble2. So its method 2 prints out mumble2. It doesn't have a toString or a method 1. So it inherits the 1 that returns Baz, and it prints out Baz1 as its output for method 1. So it overrode method 2, and it inherited these 2 from the Baz class. Again, you've got to be paying attention to the hierarchy to know which other row, you know, this mumble class would be related to. So making the table, I think, is a very helpful way to be practicing this when you're first learning it, to make sure that you've kind of got all the behaviors down just right. Let me tell you a little more about what's going on in the code that's here. So then in questions like these, I show the idea of making an array. And inside of the array, this is something we haven't seen before. I'm making an array where I put objects into the array. So I construct a new foo object, a new bar object, a new Baz object, and a new mumble object. So this array is an array that's going to have 4 things in it. These are references to objects. So zin, zin, zin. So we're going to have an element 0, 1, 2, and 3. And in this array, the first thing that goes into the array is a new foo object. So there'll be a reference here to something that is a foo object. The second thing that goes into the array is a bar object. So the second thing here is going to be a bar object. And then the third thing I put into the array is a Baz object. This would be a Baz object. And then the fourth thing is a mumble object. Now here I was also kind of trying to be kind to keep things easy, which is that I've added them into the array in the exact same order that they kind of have appeared here. So that's going to be convenient because that's going to match my table, for example. Notice foo bar Baz mumble is exactly the same as foo bar Baz mumble here. I made it all match. But, you know, to make things a little more interesting, I mix up the order, you know, in other kinds of arrays that I do. So to make sure that you're paying attention and you understand kind of what's going on here. So I have an array here that has references to various objects. And I'm going to go through the array and talk to this object first, then this one, then this one, then this one, because I'm doing a standard array traversal. I'm starting an I at 0, I'm going less than the length of the array, and I'm dealing with elements of I. So it's a standard traversal. The first time, so I'll go through this for loop multiple times. The very first time through, I'll be dealing with elements of 0. Elements of 0 is referring to a foo object. So I'll be talking to a foo object the first time through the loop, then I will become 1, and I'm talking to a bar object. I will become 2, and I'm talking to a baz object. I will become 3, and I'm talking to a mumble object. There's some interesting things going on here, and I often get questions from the class. Part of it is that people are recognizing that there's some kind of weird stuff happening here. How can you have an array where we put 4 different things in it that are of different types? How does that work in Java? There's a lot of rules associated with it, most of which, I prefer to talk about in 143. So, you could read about it in Chapter 9 if you were really interested. The parts of Chapter 9 that aren't on the calendar, because we're only reading a couple of sections, subsections of Chapter 9. We're not reading some of this other stuff. But those of you who want to understand more could do that, or wait until 143 and we explain more. But let me briefly mention the idea of what's happening here. Remember that I said that programmers, think of there being an is-a relationship. So we in setting up this hierarchy, we'd say that a bar object is a foo, a mumble is a baz, and a baz is a foo. So they all are foo in some sense. They all kind of derive from foo in some sense. And so having an array of foo works because all of these things are considered to be of type foo, even if they're kind of the extended, they're a subclass. They're all considered to be of type foo. And so that's kind of one of the things that's going on here. Again, that's kind of getting into some of the material that's more for the 143 class. So I'm not going to say a lot more about it. Let's see what happens inside of the loop. It does a println of elements I. So it's going to do a println and passing the println one of these objects. Well, we talked about this before. What does println do? Println is going to call toString. So when it figures out what to print out, it's going to print out that because it's going to call the toString method. We've seen this when we were looking at the point class. That's an implicit call on toString. It's not an explicit call. You don't see me calling toString, but we know that that's what Println's going to do. Is it's going to call toString for us. And so the first line of output, includes whatever toString would give us. And then we call method 1 on this object, which we've seen that all these method 1 and method 2s print 1 line of output. So that'll print 1 line of output. And then this will print 1 line of output when it calls method 2, and this will make a blank line. And it'll come back around. So it kind of does, 3 lines of output that have something on them, and then a blank line. 3 lines of output, and then a blank line, and so forth. So, let's just kind of go through then. So the first thing in this array is a foo object. So what's going to be the output? And I constructed my table on purpose with toString here, and then method 1 and method 2, so that it would match the order of my little println commands here. So it does this first. That it'll do the println, which calls the toString and prints out foo. And then it calls method 1, which prints out foo1. And then it calls method 2, which prints out foo2. That's the behavior of a foo object. Those are the different behaviors we get for the toString, the method 1, and the method 2. And then it does a blank line. You can kind of see that if you were going to actually do this for real on the test, in a way I'd have to give you a whole lot of extra space to be able to write all of the lines of output. But what this problem statement says, and this is not going to be important for you since you're not taking the test, but it'll be important in the sense of looking at the key, to kind of understand what the key is showing you. It says to write the output as a series of 3-line columns in order from left to right. So these are the first 3 lines of output, and then you would put the next 3 lines of output here. and then the next 3 lines here, and the next 3 lines here. So, to get it to fit on a page, I have students write it in that compact form, and that's the way it's presented in the key. So, in order to understand the key, you have to kind of know about that format. The second kind of object it deals with is a bar object. What does it do? Its toString returns foo. Its method 1 does foo1. Its method 2 does bar2. So its toString returns a foo. Its method 1 does foo1, and its method 2 does bar2. So that's the next 3 lines of output that we get, is the 3 things from this table right here: foo, foo1, and bar2. You have foo, foo1, and bar2. Then the third thing in the array is a baz object. What does a baz object give us? Baz, baz1, and foo2. Baz, baz1, and foo2 is what we get for the next bit of output there for a baz object. The last bit of output is for a mumble object, where we get baz, baz1, and mumble2. Baz, baz1, and mumble2. So that's how we would kind of show the 12 lines of output. Again, these are the first 3, the next 3, the next 3, and the next 3. So that's kind of an explanation of how we expect students to do these problems. As I said, I would encourage you to do some of these yourself as practice to reinforce what we talked about here. I want to mention a couple more ideas, and then I'll spend the last few minutes saying a little bit more about homework 7. So one of the things that I wanted to mention is think about things like when we call, say, this method 2. So there's a line of code here where we're calling method 2 in this for loop. And you say, well, what method gets called when I call method 2? Well, it changes, right? So sometimes we were calling a method that prints out foo2. Sometimes we were calling a method that printed out bar2. Sometimes we called a method that was printing out mumble2 because of the overriding, because different objects will behave in a different way when you ask it to do its method 2 behavior. It's a little bit like if I gathered a bunch of employees from the company in a room and I said, I want you all to practice applying for vacation, I'd see a lot of people pulling out the standard yellow form, but I'd see lawyers pulling out a pink form. And who knows, maybe legal secretaries have a green form, So maybe there's a bunch of different forms that people use. So I might be asking a room full of people to all, in effect, do the same thing, apply for vacation, but they're doing it in different ways. The way they respond to that request is different because of inheritance, because of the ability to override behavior and have things behave in a different way. The lawyers are using the pink form. The standard thing is to use the yellow form. Maybe those legal secretaries are using a green form. So different people would solve it in different ways if it's been overridden. Different objects solve it in different ways, depending upon whether that method 2 has been overridden. And so there's a term for this that we talk about, the idea of a line of code like this taking many forms. So polymorphism is the technical term that we use for this. And so when people are talking about inheritance, they usually are talking about not just, there's kind of different forms of inheritance, but if inheritance doesn't have this polymorphism aspect to it, if it doesn't have this ability to override, then it's not true inheritance, is what a lot of people would say. So the idea is that this one line of code can lead to different lines of output. It can take many forms. And so what you've learned here in this lecture, what you're practicing in this, is the most important aspect of inheritance, which is polymorphism. So this is a kind of, it's hard to see right now why that's important. Well, maybe actually I could give you an example of why it's important. We like the ability that we can have every one of our classes have its own toString method that kind of defines its own toString method. And then things like Println commands will kind of use our overridden toString. That's very convenient. It would be very inconvenient if it didn't work that way. So that's so the toString, the use of toString, is a good example of where polymorphism is very helpful to us. It allows us to write code that behaves better than it would otherwise. The other thing I wanted to mention before I say a few things about assignment 6 is just how this relates to the critter assignment. So there's a class known as critter, and what we did in critter is that we gave it a toString, a getColor, and a getMove. I think the default for critter is that it displays itself as a black question mark, and it always rotates left. I mean, it always does action.left as its basic behavior. So if you go to define a critter, so like if you were going to define a bird class, for example, and you said that bird extends critter, remember that I mentioned this in the Wednesday lecture, it's in the write-up, it's in the samples that you would see by looking at the food class and the flytrap class. You'll see that extends clause, that all the critters classes that we're going to define are going to end up saying things like public class bird extends critter. So we're always including that. Oops, I don't have quite enough room on one line to do that. We're always going to include that extends clause in what we're doing, so that all of our classes are going to be extending that critter class. And if you did this, even if this was empty, if there was nothing inside of this, then what a bird critter would do is that it would display itself as a black question mark whose action is to turn left. So it automatically has those different things and it inherits them. But what we're asking you to do is to override all three in the classes that you're defining. So we don't want a black question mark that always turns left. We want different kinds of behaviors. And so you're overriding in the classes that you're going to be writing there. You're not going to be having anything at a lower level. The only use you're going to be making of inheritance is to extend the critter class. The other thing that we saw that gives you is the critter class defines basically a bunch of different constants, like action.hop, action.left, action.infect. And by saying that you extend the critter class, all of those things become visible to your inside of your class. Sort of like global variables in that sense. It automatically makes them things that you can refer to because you're extending critter. So that's kind of how this plays into what's going on with the critter class. All right, let me switch back to the computer for just a couple of minutes. We'll go back to the laptop and I'll send it to the projector. So I was just going to mention that I have done the, homework 7, by the way, I think I had not updated this. I mentioned this in Wednesday's lecture, but I didn't actually update the text of it until someone pointed it out to me last night. We didn't change the due date for number 7, but we changed the cutoff. Normally the cutoff would be Friday night at 11, but this has been changed to be Saturday at 11. So we added an extra day to the cutoff. So you have an extra day to be able to finish up homework 7. You can see now I'm saying for big data that it's the final version. So I think I got 230 people to run it, which, over half the class, pretty good, for the results. So we can kind of see the final version of all of this. We ended up with almost 70% introverts, lots of introverts. I hadn't mentioned before the fact that in this personality test, there is a less specific way of describing the personality types. So, normally there's 4 letters, and so there's 16 different types that you get. But there are what are known as the temperaments. And so this is a little CSE diagram about the temperaments. Guardians, this is what I'm including in the results here. Guardians, artisans, rationals, and idealists. So if you are an SJ, you are a guardian. SP, or an artisan, NT, rational, NF, idealist. And the CSE book talks about how these things relate to the kind of classic Greek theories of personality. There's gods that are associated with these. The rationals, the NTs, their god is Prometheus, who brought fire to man, technology. A lot of NTs are scientists. The idealists, Apollo is their god. The artisans are more party people. Dionysus, the god of wine, is their god. Guardians have a kind of a boring god. Sorry, guardians, but your god is Epimetheus, who did his duty. He married Pandora when he was ordered to marry Pandora, not like his brother Prometheus, who defied Zeus and gave fire to man. SJs tend to do their duty. You can see we have a lot of SJs in the class. The big thing here that we're missing are the SPs, kind of the party people. I think that's probably true of college campuses in general. It would be kind of interesting to do a general survey. But anyway, I thought you might find that interesting. I'll mention just one last thing, which is I do think that, when I've talked to people about their personality results, they find this table here a fun thing. So, if you are an ISTP, there's kind of, that means introvert, sensing, thinking, perceiving. But this short little phrase is meant to kind of capture the essence of the type. I see the problem. And these links do lead to interesting material where it talks to you about your love life, friends and so forth, what kinds of jobs you should consider doing in the careers one, what, basic description of you. You could think of this as a kind of scientific astrology. We ask you a bunch of questions, we put you into categories, and then tell you what you're like. So anyway, if you're interested, you could check it out. But that's going to be the last time that I talk about homework 7. And we'll do more in Monday's lecture, talking about some of these more advanced topics and what would have been on the final if you were doing the final. Again, I think it's very useful material to understand. Monday's lecture in particular is really useful aspect of Java, very practical aspect of Java that you're going to want to know, even though you don't have to do a final exam question that involves that. Okay, so that's it for now.